Hello, I will present the following research as a part of my doctoral thesis entitled Spatial Distribution and Beta Diversity of Benthic Macrofauna in Sandy Beaches of the Atlantic Coast of Mexico. Benthic macrofauna is a key component of intertidal marine ecosystem. It has a discontinuous distribution restricted to latitudinal gradient of the geographic region. Determining the causes of species diversification remains a central aim for ecology, and it's crucial for the sandy beach ecosystem. In the Atlantic Coast of Mexico, which includes the Gulf of Mexico and the Caribbean Sea, there are still many gaps in information on the macrofaunal species richness and the distribution patterns. Since the publication of Dexter, who made the first attempt to describe the richness of sandy beach macrofauna along both coasts of Mexico, and the later contribution of Mendez Ubach, Rocha Ramirez, Hidalgo, and GUERRA-CASTRO and colleagues, who analyzed the species diversity related with the development of oil industry of the Yucatan state, many gaps in information remains empty. Understanding the spatial variation of benthic macrofauna diversity through studies that quantitatively assess the distributional patterns for this very dynamic environment can derive in a better knowledge of macroecology of sandy beach macrofauna on this highly complex region of the Western Atlantic Ocean. The study area ranged from Tamaulipas in the northern Mexico to Quintana Roo in the southeastern Mexico. Data from 648 quantitative intertidal quadrants from 16 locations in 6 marine ecoregions were obtained to try to identify macrofaunal assemblage structure. Sampling was carried out in February and March 2020 and 2021. Sampling yielded 14,013 individuals of 42 species. The taxonomerical dominant were Arthropoda composed by Paracarida and Decapoda with 83%, followed by Annelida polychaeta with 13% and Mollusca bivalva with 4%. In this slide, we can observe the complete list of species abundances in the 6 ecoregions considered in this study. The distribution of species richness exhibit a consistent trend, with high values for all coastal states except for Tabasco, which registers the lowest specific richness values. Meanwhile, the density values were relatively low for all states, except for Nautla and in Veracruz state and Sabancuit in Campeche state. Low species richness and densities could be occasioned by human activity, for example, coastal infrastructure and marine pollution. In the specific case of Tabasco, with lowest values in both richness and density, this could be occasioned by oil industry, which impact this part of the southern Gulf of Mexico remarkably every year. The spatial distribution trend under the null hypothesis tested by PERMANOVA indicates absence of difference between ecoregions based on the species composition of benthic assemblages. The table of PERMANOVA results shows a pseudo F value of 8.93 and a p-value less than 0.005, supporting the rejection of the null hypothesis and the acceptance of the alternative one. That is, that there are differences between ecoregions based on the species composition of macroinfaunal assemblages. The NMDS ordination evidence difference in the faunal resemblance between terrigenous and carbonate sediment-influenced ecoregions. As well, the ordination in the cluster, we can observe a similar pattern in which there are 3 major faunistic groups related with the sedimentary habitat. The spatial species diversity analysis using the additive partitioning approach estimate an overall beta diversity value for the total area with the beta-sor index of 0.8 and 19. However, when beta diversity was partitioned in turnover and nested components, the spatial turnover was responsible for the most beta diversity structure in the macroinfaunal of assemblages with a βsim value of 0.7 and 16 versus a beta nest value of 0.103. The higher dissimilarity structure of the assemblages occurred between the Cancunian neritic with the rest of the ones. In the southern Gulf of Mexico, the higher dissimilarity occurred between the Campeche Yucatan inner neritic zone, a carbonate sediment origin zone, versus the Tabascan, Veracruzian neritic, and Western Gulf, with a terrigenous sediment origin. We conclude that macroinfaunal assemblages on the sandy beaches of the Atlantic coast of Mexico are mainly structured by species replacement. Furthermore, the assemblage structure seems to be influenced by the sedimentary origin of the studied locations. These factors could act as a barrier to conditional the regional assemblage structure. More extensive research that includes the spatial and temporal components of the sandy beach of macrofauna of the Atlantic coast of Mexico is necessary to understand the ecology and generate legislation that intended to protect this critical endangered habitat. That's all for my part. If you have a question, please contact me. Thank you.